All right, lesson 20 from Unit 5 is going to be on what's called the central limit theorem. Here's the idea with central limit theorem. So let's say you have in your class a test where the average was an 80. What would be the probability of picking somebody who had a test score that was 90 or less? Okay. So there's a pretty good chance that you're going to pick somebody that had a test average that was 90 or less. But, you're going to get some kids that, got 93, 95, 100 and something like that. So, it's going to be depending on what the standard deviation is. If the standard deviation is a 1, it's going to be pretty high for that to be. But in any case, there's a pretty good chance that you would do that. What if I picked a group in that class? I picked a group of 5 students and took their average. And if I wanted to know if that average, the probability of that being 90 or less, that's actually going to be higher. There's going to be a better chance that if I pick, 5 students, there's going to be that one student in there that, got a 40% on it or something like that. So by taking a group of people and taking their average and comparing it to the average of the whole, how does that affect the answer? So we're not just taking one individual. That's essentially what we were doing in the last two sections. In this one, what if I'm taking a group of people in that larger group and finding their average and comparing it to the average of the whole? So if I change the question and say, okay, if you've got an 80% and I want to know the probability of picking somebody that's getting a bigger than 90%, well, there's some people that got bigger than 90%. There's going to be a halfway decent chance that that's the case. I mean, it's not going to be 80% or anything like that, because if the average is 80, and we're going to 90, but say it's 15% or something like that. But what if I take 5 students and I average their tests? What's the probability that that's greater than 90 if the class average is an 80? Well, that's going to be less, because what if you get somebody in there that got a 40? So taking those groups, again, affects the probability of this happening. So that's what central limit does. So central limit means essentially if you take a group of people in a larger group, you take a large group and you take some of those people and take their average. The more people you pick in that group, the closer it's going to turn out to be. The probability of it being closer to the whole group average is better. So what ends up happening is the standard deviation changes and it gets smaller. So the more people you pick, the smaller the standard deviation is, because it's going to move you closer to the mean. And the formula that you would use for that is the standard deviation divided by the square root of however many people you're picking. Right? N is what we would call that. And the larger the n is, the closer to normal it's typically going to be. So in this question right here, as I pick, say, 2 people, or if I pick 5 people, or I pick 10 people, or I pick 19 out of the 20 people, that average is going to get closer and closer and closer to the whole entire group average. Okay, so the standard deviation is going to shrink when you do that. So what you're looking for in these problems is a group of people. So if I'm choosing, in this case, 20 people, the wording that you're going to see is find the probability that the mean. Okay, so because we're not just talking about one person, we're talking about 20 people and using their average. Okay, so same thing down here. We've got 20 people, probability that they're mean. This one here, we've got 40 people, probability that the mean. Notice on this one here, find the probability that a person, okay, not 20 people, not 40 people, but one person. So you don't have the words probability that they're mean because it's only one person. 8 people, probability that the mean. 14 people, probability that the mean. Okay, so that's the wording you're going to look for. Doing the problems is almost exactly the same as what we did in the last section. All right, so you've got a mean of 25. So this is children between the ages of 2 and 5. Their ages actually don't matter for the problem. Watch an average of 25 hours of TV per week. It's normally distributed and distributed, excuse me. The standard deviation is 3. Okay, so we've got a mean here of 25. I want to know that if I have these 20 children, what's the probability that their mean is greater than 26.3? So normal CDF, 26.3, infinity. Mean is 25. Standard deviation is 3, but because now I'm doing a group of people, I'm going to do a standard deviation of 3 divided by the square root of those number of people. That's where the change is. All right, so you type it in still kind of the same way here. So we've got 26 infinity mean standard deviation. Make sure you do divided by the square root. It's not times the square root. Okay, so we get 6.8%. All right, if this problem would have been one person, not 20 people. Oops, I can just do this. Yeah, wrong button, sorry. Let's take off the 20, square root of 20 at the end here. See, it's a much higher probability that you'd have one person that would be greater than 26.3. So it kind of depends on which way you're going. If you shade over the mean, then these numbers, when you're dividing by the square root, are going to be greater than if you didn't take a group of people. Whereas if you're going in the opposite direction of the mean, dividing by the square root of 20 is going to shrink that answer. I'll show you what I mean by doing a couple more here. All right, so average number of pounds of meat a person consumes in a year is 218.4 pounds. That's actually true. Assume that the standard deviation is 25. I want to find the probability that a person consumes less than 224. So 218.4, 224, less than that. So normal CDF, negative infinity, 224, 218.4, standard deviation is 25. Okay, and we're doing one person. You could divide it by the square. You could do this divided by the square root of 1 if you wanted to, but it's still going to be 25. As always, double check your numbers as you're typing them in. Be careful that you're typing in the correct numbers. So we get 58.9. Okay, same picture now, except I'm going to do this for 20 individuals. So take those 20 individuals, find their mean. Is that going to be 224 or less? The probability that it'll be 220. So same picture. I'm not going to draw the picture again. Now this time, negative infinity, 224, 218.4, 25 divided by the square root of 20. Okay, now this one should be a better chance of that happening. So I'm pulling that back up by just doing second and the enter button. It pulls up the exact same problem there, because then I can just change the standard deviation to that divided by the square root of 20. 84.2%. Okay. Um, what if I do that for, same problem, except now it's 40 instead of 20. So exact same problem as there. 25 divided by the square root of 40. And as hopefully you figured out, you're going to get an even bigger possibility of that, so 92.2%. Okay, now this time, so what was it, 220, 218.4. I want to know greater than 230. All right, so 230, 218.4, 25 divided by the square root of 8. So 9.5%. And now if I change the problem, but now I'm taking it for 14, so think about this. So it is going bigger than that. Dividing by the square root of 14 should move their average closer to the mean. So this number should be smaller when I do this one. Change the 8 to a 14. So 4.1%. All right, so that's central limit. So again, the trick that you're looking for is we are taking groups of individuals and finding the probability that their mean is greater than or less than or whatever the question happens to ask. All right, so that's lesson 20 from unit 5. Let me know if you have any questions.